Today I'm going to teach you how to simplify uh, Today I'm going to teach you how to simplify fractions using Euclidean algorithm. Okay, so what is Euclidean algorithm? Euclidean algorithm uses division to find the GCF, or the greatest common factor of two numbers. So just a quick recall, what is GCF, or the greatest common factor? So greatest common factors is used to simplify fractions. So for example, 12 over 30. The GCF of 12 and 30 is 6. We're going to use 6 to divide both of these. So 12 divided by 6 is 2. 30 divided by 6 is 5. So when you simplify 12 over 30, the answer is 2 over 5. So the question is, how do we get GCF? The common method to get GCF is using factor 3. So we're going to use 12 and 30 again as example. So first is we're going to factor out this number. So what do you mean by factor out? We're going to factor the multiplicand and the multiplier of the 12 until we get the prime numbers. The prime numbers. So what do you mean by that? So we're going to simplify 12. So what numbers can we think of when multiplying, that are used to multiply 12? So what that get in mind is 2 and 6. So this is a prime number. So but 6 is not. So we're going to factor this out again. So what numbers can I think of when to multiply and to get the what numbers can I think of to get the product of 6? What came to mind is 2 and 3. Both of these numbers are prime numbers, so we're good. We're done with factoring number 12. Let's move on to the next number, which is 30. So same process, we're going to factor 30. 2 and 15, that's the number that came to mind. Then we're going to simplify 15 because 15 is not a prime number. So numbers that I can think of is 3 and 5. As you can see, all of these are prime numbers now. So next is we're going to find numbers that are similar to both of these. As you can see, 12 got a prime number of 2 and 13 got a prime number of 2 as well. 2. But 12 has two number 2's as factors. Well, what we want is to get similar prime numbers from both equations. So we only have one number 2 here, one number 2 here. So we're just going to get one number 2 here as well. Then we're going to write it down here. Next is we're going to find the next prime number that both of these equations have. As you can see, they both have number 3. So we're going to write it down here as well. Number 30 has a prime factor of 5, but 12 doesn't. We're not going to write number 5 because, as stated earlier, both numbers or both equations should have the same prime numbers as their factors. But 12 doesn't have a factor of 5. So this is what we got, 2 and 3. Then these factors, we are going to multiply it. So 2 times 3 is 6. That's the greatest common factor. This method is a bit tedious, but simple. This method is good for factoring out smaller numbers, which is similar to this. But what if we are given an equation or some problem, and the numbers given, let's say for example, are in thousands or 10,000s, and we are asked to find the greatest common factor of those numbers. Using factor 3 will be hard because we're going to factor the multipliers of, let's say, 1000. We're going to find the factors and GCF of that. And 1000 is a big number. It will take us a lot of time just to factor it out. But by using Euclidean algorithm, we're going to lessen the time spent to find the greatest common factor. So what is GCF? What is Euclidean algorithm? So it consists of dividing two numbers, so 12 and 30 again, as the example. So for the Euclidean algorithm, first we need to find the bigger number of the two. As we know, 30 is bigger than 12. So we're going to use 30 as the dividend. Then the smaller number as the divisor. Why did we do that? Because we want to find the remainder when you divide 30 by 12. Because Euclidean algorithm needs to divide numbers repeatedly until we get the remainder of 0. So once we get the remainder of 0, the divisor used to get a remainder of 0 is known as the GCF. What sounds complicated? I'll show you what I mean by that. So first, we want to divide these numbers. So 30 divided by 12 is 2. 2 times 12 is 24. 30 minus 24 is 6. Then, as you can see, the remainder is not 0, but 6. So what we will do is repeat the process, but this time we're going to use 12 as the divisor, as the dividend, then 6 as the divisor. Okay, repeat the process. 12 divided by 6 is 2. 2 times 6 is 12. 12 minus 12 is 0. So as we can see, we got a remainder of 0. So what divisor did we use to get that remainder of 0? The answer is 6. So once we determine what divisor is used to get a remainder of 0, that number is the greatest common factor of the two numbers. As you can see, we only use the division process 2 times. I think it's much quicker than using the factoring tree method. Okay, I'm going to find the GCF of two numbers again. So for this one, I'm thinking of using 30 and 44. Okay, 30 and 44. If you want to try this with me, I would appreciate that. That would be cool because you're going to get the hang of the Euclidean algorithm much better. So 30 and 44. 30 and 44. Okay, so firstly, we want to determine which of the two numbers is bigger. As you can see, 44 is bigger, so 44 will be the dividend. Then 30 as the divisor, the one that is used to divide the larger number. Okay, so 44 divided by 30 is 1. 1 times 30 is 30. 44 minus 30 is 14. As you can see, we didn't get a remainder of 0. So we will try to divide numbers again. So this time, 30 is the dividend and 14 is the divisor. 30 divided by 14 is 2. 2 times 14 is 28. Then 30 minus 28 is 2. We still didn't get a remainder of 0. So we're going to repeat the process. 14 as the dividend now. Then 2 as the divisor. So 14 divided by 2 is 7. 7 times 2, 14. 14 minus 14 is 0. So the greatest common factor of the two numbers is 2. Okay, do you want to see what it looked like when simplified? Okay, so 30 over 44. 30 divided by 2 is 15. 44 divided by 2 is 22. As you can see, this is the simplest number that we can get. Because when you use the factor tree, what prime numbers we get when we factor them out is 3 and 5 for 15 and 11 times 2 for 22. As you can see, there's no similar prime numbers between these two numbers. So this is the simplest fraction that we can get, 15 over 22. I hope that you understand this lesson, and I hope that you can use it for your exams or quizzes. Thank you for watching. I'll see you in the next one. Peace.